Hi, it's Carly McAvoy. I'm talking about solving radical equations today, and in this video I'm going to show you 5 examples. Some are pretty easy, the last one's pretty complicated. And the thing about radical equations is sometimes you can get extraneous solutions, and we'll see an example of that near the end of the video. So if I have a radical in my equation, I can get rid of a square root by taking it to the second power. Remember, a square root means 1/2 power. So if we double that, we get 1 power of 1, which just makes it x. So if I have this equation, square root of x equals 9, I would start that by taking both sides to the second power, and then I would simplify that because the square root of x to the second power is just going to be x, and then 9 squared is 81. Always when you're doing a square root equations, radical equations, you should be checking that. The square root of 81 equals 9, that check, all good. All right, in the second equation, we have the square root of 3x minus 4 equals 2. And so now it's the same thing as up here. I have a radical equaling a number. If we can isolate our radical on one side, we can just take the square root so easily. And so that's what I'm going to do is go ahead and square both sides just like I did before. And that gives me just the square root of something to the second power and the other side to the second power. The square root and the second power, we can think of those as canceling each other out. Really, it's 1/2 times 2. And so that makes this then become just 3x minus 4 equals 2, equals 4, sorry, because 2 to the second power. Just like any other equation, then we're going to add 4 to both sides. That's going to give us 3x equals 8, and then we would divide both sides by 3, and we would get x equals 8/3. We would still want to check that just in case. And we look here, we can see plugging in over here for x, we're going to plug in the 8/3. The 3's are going to cancel, making that 8. And then minus 4 would be 4, and the square root of 4 is 2. So everything checks out. Those are nice, the easiest ones. This next two aren't too bad. And then the last one's pretty complicated. So here, what I want to do first is isolate my radical, and I'm going to do that by adding 5 to both sides to start. And I kind of, this one was a little bit too big, so I had to do this. But if I add 5 to both sides, then that minus 5 goes away. And on the other side, you can see that I would get 16. And now I have this, I'm going to divide both sides of the equation by 2, so I can continue to get that radical by itself. And that's going to give me just the square root of x equals 8. And now we're back to what we were like up here, where we have a square root equals a number. We're just going to take the square root of both sides. We're going to take the square of both sides, sorry, and that square of the radical is going to give us that radicand, which is 8, and 8 squared is 64. And now I'm just going to see that x equals 64. I can still check that by plugging that in. 2 times the square root of 64 minus 5 looks like 2 times 8, which is 16, minus 5, which is 11. Also checks out, no worries. In this particular problem, we're going to start off by taking the square root of both sides, just like we did up here in example 2. And if I take the square of both sides, it looks like that. This radical is going to cancel with the second power, and that's going to leave just the 2x minus 7, 2x squared minus 7, and the 5 squared is 25. Like I did before, I would then simplify this by adding 7 to both sides and getting 32. And then once I did that, I would divide both sides by 2, which would give me x squared equals 16. Now, we have been taking things to the second power to solve, but remember, we can also take the square root to solve. That's like the square root property that we have done in other videos. So if I take the square root of both sides, well, now I need to remember that if I take the square root of both sides, I get 2 solutions. And so that gives me then x equals 4 and x equals negative 4. And so that's 2 different solutions, and that makes sense because look what we have under here. We have an x to the second power. When we have something to the second power, we expect two solutions. So when I do my check, I need to check both of those. But you can see what we're doing here is we're taking that number to the second power. So whether it's 4 or -4, doesn't matter. In both cases, we're going to get 16 times 2, which is 32, then -7, which is the square root of 25, and we get equals 5 like it was supposed to. And both of those are solutions, two solutions, because we had an x to the second power. Up here we had x to the first power, x to the first power, and so forth. But when we get x to the second power, it makes sense that we're going to get two solutions. Okay, here's the most complicated one, because see how complicated this is? We got this x in here and we got this other stuff. So what I would do first for this one is rearrange to get my radical term by itself. That is, I'm going to move that -5 square root of x to the other side. When I do, I'm adding it so it becomes positive. And then I'm going to subtract 2 and move that to the other side so that +2 becomes -2. Now I could go ahead and divide everything by 5, but look how messy that's going to be. I'm going to have this fractions in there, so I don't want to do that. I just want to go ahead and take the, to get rid of the radical, I want to go ahead and square both sides as they are right there. So that means I'm going to take 3x minus 2 to the second power. Notice I do not individually take the second power of the first term and the second power of the second term. You have to take the square of the entire side. That requires that you use some of the skills you learned in polynomials, and we're going to use factoring. There's a lot going on in this problem. Now, what I really have here, when I take that to the second power, is I have 3x minus 2 twice. 3x minus 2 times 3x minus 2 is 3x minus 2 squared. And what I really have on the right side is 5 square root of x times 5 square root of x. And that's important because a lot of times people will get 5x over here instead of realizing that the 5 is going to the second power as well. So when I square that out, what I get here is I get 9x squared. This is just the FOIL. The first terms are 9x squared, the outside -6x, the inside -6x, and the last is +4. And over here, 5 times 5 is 25, and the square root times the square root is just x to the first power, because this is like a half power and a half power. Add those together, you get 1 whole power. And so the next thing I would do is go ahead and move my 25x to the other side and set the whole thing equal to 0. So over here, I don't know why that's happening. Over here, you can say I have 9x squared minus 6 is minus 12, and then minus 25 makes that a total of -37x. And I chose this because it is kind of a nasty problem, and I want you to see how, well, sometimes you have to face something pretty nasty. The other thing I want you to see is that we now have an equation to solve that's going to require factoring, or you could use quadratic square, however you solve quadratic equations, complete the square or quadratic formula, I mean. But I want you to see that we started off with x to the first power, and through doing legitimate math steps, we have now gotten x to the second power. When we see something to the second power, we expect two solutions, but our equation has only one power, and that's when the extraneous solution thing comes into play the most. I mean, you always should be checking, but that's when you're really like, oh, wait a minute, why should I be getting two of those? The next thing you're going to do is factor this equation, and I'm going to go ahead and delete whatever I've got covered up here, because you have to factor it, and it factors into 9x minus 1 and x minus 4. I have a ton of videos about factoring. You probably have some method you like the best, but that's what you're going to do. And then after you factor, you're going to set each of your factors equal to 0, and then solve. Adding 1 here and dividing by 9 gives you 1/9, and adding 4 over here gives you 4. So you factor and you set each of your factors equal to 0, and then solve. So we have two possible solutions here. But let's look at the check for the first one. If I have x equals 1/9, 3 times 1/9 is 1/3, and then 5 times the square root of 1/9 is 5 times 1/3, and that is not going to equal 2. So that is not a solution, it's extraneous. Sometimes you get extraneous solutions in the process of solving using these methods that we use. We didn't do any bad math. We just need to remember that sometimes doing good math can lead to extraneous solutions. So did the second one work? Well, 3 times 4 minus 5 times the square root of 4 is 3 times 4 is 12. The square root of 4 is 2. 5 times 2 is 10. That does equal 2. So x equals 4 is a solution. That's the only solution. Not 1/9 is not a solution here. And just to put that into words, the original x up here is to the first power, so we would only expect to get one answer. And we got 2. That's when we have to kind of go, whoa, we need to check to see if we got an extraneous solution. All right, that's it for radical equations. Have a fantastic day, and I'll see you next time.